Okay, so number 6 wants to know whether this function is odd, even, or neither. So, I mean, first thing I always do is I determine, if once they give us f of x, I find out what f of negative x is equal to. Because whether you're working with even or odd, you need to check f of negative x. And, you know, right away, when you check that, if it's equal to the original function, you know it's even, and you can stop. So let's start with that. All right, so we'll do f of negative x. Okay, well, all that means is you're going to replace all of your x's with a negative x. And make sure that when you do that, you put them in parentheses. Okay, now if you recall, when you take a negative and raise it to an odd power, it's negative. When you take a negative and raise it to an even power, it's a positive. All right, so let's keep that in mind. Let's bring this down. F of negative x is equal to, so a negative to an odd power is negative. So this is really going to be equal to negative x to the fifth. So 5 times negative x to the fifth will be negative 5x to the fifth. All right, so then negative x to an odd power, again, is negative. So this is going to be negative x cubed. So negative 8 times negative x cubed is going to be positive 8x cubed. And then 2 times negative x is just negative 2x. Now you could see right away that the original function f of x is not equal to f of negative x. So since f of x is not equal to f of negative x, we could say it's not even. Okay, this statement right here is not true. All right, so let's check if it's odd. To find if it's odd, we now need to look at negative f of x. So negative f of x just means you take your original function here and you negate the whole thing. So you could just put a negative symbol in front of the whole original function. Okay, now what we can do is we can distribute that negative to each term in our function here. So I'm going to bring down negative f of x, and when I distribute my negative, a negative times positive 5x to the fifth is negative 5x to the fifth. A negative times a negative 8x cubed is positive 8x cubed. And a negative times a positive is a negative, so negative 2x. Okay, now when we look here, you can see that this and this are the same. Okay, these are the same thing. So, because f of negative x is equal to negative f of x, right? Isn't that what our rule says right here? We could say that this function is odd. So let's write this out. We can say it's odd and just give an explanation, because negative f of x is equal to f of negative x. Now, I'm always a fan of checking these in the calculator, because if you remember, even functions are symmetric with respect to the y-axis. So what that means is if you fold along the y-axis, one half of the graph will fit directly on top of the other half of the graph. And odd functions are symmetric with respect to the origin. So, I mean, that basically means if you just take your paper and just turn it upside down, you'll see the exact same image. So if you graph this in your calculator, you'll see, I'm just going to do a real quick sketch, but you'll see something that looks like that. And if you took this and flipped it upside down, you would see the same exact thing. So this is odd. Okay, so number 7 asks you to determine whether f of x is odd, even, or neither. Now, I have our rules up here for even and odd, so let's just check them out. All right, I first like to determine f of negative x, because you need that whether a function is even or odd. And if it's even, once you determine f of negative x, if that's equivalent to f of x, then you're done. So let's try it out. Okay, so let's first find f of negative x. Now what that means is you're just going to go through and you're going to replace all of your x's with a negative x. So in the numerator, we're going to have a negative, and then in parentheses, negative x to the fifth, and then plus, in parentheses, negative x cubed. And that's going to be all over negative x. All right, so let's kind of take a look at this and see what we can do. Let's see if we can make this look like our original function, because if it is, then we can say it's even. All right, so when you take a negative and raise it to an odd power, it's negative. So we're going to have negative x to the fifth. Now, since we have a negative out here, a negative times a negative x to the fifth makes that positive x to the fifth. All right, then again, we have a negative being raised to an odd power. So that's going to become negative x cubed. And a positive times a negative is a negative, so I'm just going to write minus x cubed. And then in our denominator, we just have a negative x. There's not much we can do with this. Now at this point, if you were to look at f of x and f of negative x, you could say these two right here don't appear to be the same. But with fractions, I mean, you can kind of factor a negative out of the top and distribute it to the bottom, or you can factor a negative out of the bottom and distribute it to the top. So let's do that. Let's do a little bit of maneuvering and see if we can get these to look the same. So if you notice, our original function has a positive x in the denominator. This has a negative x in the denominator. Let's just say we took this negative x and pulled it out in front of the fraction. Okay, so I'm going to take this negative x right here and bring it right to the front. So now we're going to have negative, and we're going to have, just an x on the bottom. And our numerator doesn't change at this point. Okay, so now let's take that negative and distribute it to the top instead, and let's see what happens. So we'll have a negative x to the fifth, and then a negative times a negative is a positive, so plus x cubed over x. Now if you look, the original function and f of negative x are the same. So what we can say here is that our function is even. Okay, we can say it's even, and to give an explanation, because f of x equals f of negative x. All right, there's a couple more things I just want to say about this problem. There was really a shortcut to do this. I'm just going to write shortcut here. All right, if you look at this original function here, right, we could have taken both terms in the numerator and just divided it by that x in the denominator. So if you did negative x to the fifth divided by x, that would be negative x to the fourth. And then x cubed divided by x is just x squared. So really, you could have written our function without a denominator. You could just, have an expression here, so not a fraction. So now if we wanted to find f of negative x, I'm going to bring down this negative sign. I'm going to replace my x with a negative x. I'm going to replace this x with a negative x, and let's see what we're left with. So when you take a negative and raise it to an even power, it becomes positive. So here we have positive x to the fourth. So a negative times a positive x to the fourth is negative x to the fourth. And then here, again, a negative to an even power is positive. So we have positive x squared. So positive times a positive is positive. So plus x squared. So you can see here that these are the same. So if you had reduced this fraction, it was a lot easier to see that they're even. Now just to double check, you can take out your calculator, and remember, an even function is symmetric to the y-axis. So if you were to graph this in your calculator, it just looks something, I'm just going to do another quick sketch. It looks something like this. And if you were to fold along this y-axis, you could see here that one half of the graph would fold directly onto the other half of the graph. Okay, so number 8 asks us to sketch a graph of f of x by finding the zeros and determining the sign of the values of the function between the zeros. So the first thing we want to do is we want to find our zeros. So if we were to have made a t-chart and set this equal to 0, we would see, negative 4 equals 0 would cancel off, but we would have a 0 at x equals negative 4, x equals positive 3, and x equals negative 1. Okay, so from this point, let's just make a sign chart. Okay, don't forget to label it f of x. Let's put our zeros on that sign chart. So we have -4, -1, and +3. And we only have to determine the sign of the values between the zeros. So we only have to test an x-coordinate in here and an x value in here. Okay, if it didn't say between the zeros, we'd have to test one less than -4 as well as greater than +3. Okay, so I guess a number between -4 and -1 is -2, so we're going to find f of -2. And then I'm going to choose a number in between 1 and 3, so I think 0 is an easy one to pick. Okay, so all you're doing is you're just taking these numbers and going back to the original function. So if I take a -2 and substitute it into all of my x's here, this is what's going to happen. Now, on the outside of the parentheses, we have a negative number. We have a -4. So I'm going to take that negative sign and bring it down. Okay, we have to take that into consideration. Now, if I plug in -2, -2 plus 4 is a positive number. So in that first parenthesis, I'm going to have a positive. All right, then if I plug in a -2, -2 minus 3 is a negative value. So I'm going to put a negative here. And then -2 plus 1 is also a negative value. So a negative times a positive times a negative times a negative. When you have an odd number of negatives, our value is going to be negative. So let's put a negative here, and you could put that negative right up there in your sign chart. Okay, so now let's take this 0 and substitute it in. Well, we have a -4 on the outside, so we again have to take that into consideration. So let's put a negative out here. Okay, and then within our first parenthesis, if we plug in a 0, 0 plus 4 is +4, so positive. If we plug a 0 into the next parenthesis, 0 minus 3 is a negative. And then if we plug in a 0 into the last one, 0 plus 1 is a positive. So this time we have 2 negatives. So when we have an even number of negatives, our answer is going to be positive. So let's put a plus sign here as well as here. Okay, so time to graph this. I mean, once we have our sign chart made, the graph is pretty straightforward. So we're going to set up an x-axis and a y-axis. And we know that our graph goes through the x-axis at -4, -1, and +3. And then, I mean, if you want to label those, you can. And then whenever we see a negative on our sign chart, it means our graph is below the x-axis. So between -4 and +1, our graph is going to be below the x-axis. And then when we see a positive on our sign chart between -1 and 3, it means our graph is going to be above the x-axis between -1 and +3. So here's our graph. And just make sure you label it f of x. Okay, always remember to label your graph and your sign chart with f of x.